Welcome to Math Analysis for April 6th. We are going to talk about what we do when we see some variables in denominators and we need to make derivatives of those. Now, before I get into the video, quick announcement. This week was originally scheduled to be our spring break at school starting on Wednesday. And even though we've been out of school for the last 3 weeks or so, I still want us to observe that, right? Like, you guys weren't ever meant to have to work and practice and prep on those days at all, and I want to keep it that way. So we're only going to have 2 videos this week, today and tomorrow. Starting on Wednesday, all the way through next Monday, our original scheduled spring break, we're not going to have videos. You guys are going to get to take it easy, right? Well, as much as you have been for the last 3 weeks. But we will be returning with videos next Tuesday. So, without further ado, let's talk about these variables in denominators. Now, typically, if we see variables in denominators, it's really not any big deal. You know, we're putting them in an equation, or we're multiplying them, or whatever it is. You know, in Algebra 2, we're working with rational expressions, and it's not any big deal for variables to be in denominators. But when we're trying to find derivatives of these equations with variables and denominators of fractions, it makes it a lot more difficult. And for us to be able to use the rules that we've already established with derivatives, we don't really want them to be in the denominators. So we're going to talk today about how to move them, and then tomorrow we'll do some actual examples with some equations that look like this. So here's the deal. You guys have noticed or seen some negative exponents in this packet already, like x to the negative fifth, whatever it may be. What it is a variable in the denominator is actually a variable with a negative exponent that could be in the numerator. So what you can do is you can pick up this variable and put it up here as long as you write it with the same variable it currently has, but negative. That makes it go away. Now the deal is, you could do it vice versa too. If you have a variable in the numerator, you can put it in the denominator by making it the negative version of what it is, right? Like if you had z to the negative 7th up here, you can take it and put it in the denominator, take a negative of the negative 7, becomes positive. Or you just flip the sign, if that's how you want to think about it. Even if this was a negative down here, you flip the sign to put it up there. You can move variables around to whichever side of a fraction you want it to be in, as long as you change the sign accordingly. Similarly, right here, we have a number in the numerator already, but we would be able to pick up this x to the 4th, put it up top, and we would rewrite this as 6x to the negative 4th. Because again, by picking up this variable, putting it in the numerator, we are making the exponent with it negative. We just flip that sign, really. That's probably the better way to think of it, is just flipping the sign of that exponent. So now let's take a look at this one. This is the kind of problem where it really, you may have some questions. Because you start thinking, okay, well, I need to move that x to the 3rd. I'm going to move it to the top, it's going to become negative. But what happens with this 5? Does that 5 move with it? And the answer to that is that unfortunately it does not. That 5 stays where it is. Because to move a variable and to change up its exponent and all that, we only move what that exponent is actually attached to. Meaning, this 3 is only attached to that x. So we are only going to move this single term up to the numerator. The 5 will stay where it is. So technically, this would be 3x to the negative 3rd over 5. But I also think that for derivative purposes, that may be not the best way to write it. Instead of 3x to the negative 3rd over 5, making it look like that 5 has to apply to the entire equation, we could write it like this. 3/5 x to the negative third. The reason I think this is a little bit easier is so that whenever we do start taking these derivatives and we multiply this number by the numerator, we know that we're multiplying that whole fraction, and it kind of changes as an entire number, right? We saw this last week whenever we were working with fractional exponents and those fractional exponents were moving to the front. This is written in pretty much the exact same way. Both of these ways of writing it are correct, and truthfully, it just is up to you which one you're more comfortable with. Finally, we have a problem like this, where instead of just having a variable in the denominator, we have a whole radical and all that mess, right? So if we solve something like this, or if we simplify or change the form of something like this, my recommendation is that we go ahead and simplify the radical into a fractional exponent first. So instead of writing this as 2 over the 9th root of x to the 4th, I want to write this as 2 over x to the 4/9. So that way, when I move this variable to the top of the fraction, it would be written as 2x to the negative 4/9 power. That way I don't ever have to worry about mixing up my variables, or what about this do I make negative, all those kind of things. You don't got to worry about all that stuff. If we simplify it first and then move it, I think it takes a lot of the guesswork out of the problem. So this was the plan for today. How to move variables and denominators, and how to make all these fractions that we're seeing in questions like, I think it's like 9 through 12 or 13 or so on the packet, how we can eliminate the fractions and instead write them just as whole numbers or numerators, however you want to think of that. Tomorrow we'll actually do a couple of the problems as practice. So if you have any questions before then, feel free to email me. Otherwise, I'll see you then.